Internet is a bit slow. Any question, please let me know. Jahanzeb, do you have any question, please? Muhammad Jahanzeb, do you have any question? Your hand is up, please. Arsalan, do you have any question?
Yes, sir. How the attendance is going to be marked? We have to say something or something like that?
No, so I'm taking, did you check? So I'm always taking download attendance list from here. Online session, we are taking it from the Microsoft application, Microsoft Team application. So once you are in, so you are recorded, so you don't need to worry about it.
Okay, thank you, sir.
Okay, so I'm taking random instances, not just a start. Yes, please.
So my question is, when we'll get the previous lectures link down, recorded link?
This must be in the same session. The one I'm using, there will be file section on Teams. Go to Teams, open with laptop. Right now, it shouldn't be accessible because everybody's in the link now. Once link is off, nobody is active, then you will be able to get it. Yeah. Otherwise, let me know. I will share my previous recorded videos.
Thank you so much, sir. Okay.
Don't worry. Just try to focus try to listen what we are saying. This is super easy. If you listen, trust me, you will pass easily and don't miss anything. You follow the requirement exactly. This should not be any problem. So this module, I know some students, they are from IT background. They will pass easily without any problem. More than 70, 80, A grade, B grade, A2, something like this. But some students, they might be struggling because their limitation is because of IT things. So don't worry. So I will provide full support. Might if you need any help with sample thing, with feedback thing, I will come down to campus to support you. Okay, so don't worry for anything. Yeah. It should be super easy if you listen us carefully. Yeah. And we are keeping modules very simple and basic, just in case everybody can pass it. Yeah. Otherwise, this module can be, more technical with more design development, kind of, virtualization things like, packet tracer, GNS3. But this is not the case. If you wish, you can do it. Otherwise, this is normal for all of you. I think this is time. Let me finish something first, then I will come to answer your all questions. If you have no serious questions, so I'm just going ahead, please. Yeah. So we are going into a recording mode right now. Just make sure everybody will be recorded. This is consent. I'm getting permission for all of you. Then I will finish my lecture. Then we will discuss one by one. Your all question, all things, whatever do you have, don't worry. So let's start now. This is again a reminder for all of you. Make sure that scheduling for the submission is already designed. This might not be accurate thing, might be possible thing, but make sure this is designed. So please don't forget it. Maybe I said it's 27. It's coming very near. Maybe we can go ahead with 26. Maybe we can go 29th of September. So please make sure your presentation submission is coming very soon. So you don't have to waste your time. So please be proactive right now. So this submission, the BDCN, if you would like to pause, make sure this is in every recording. I would say if any student mistakenly submitted this more than 1 week, so you will be failed. If any student didn't submit this individual part, this is just 10%. If you submit, you will get 5 to 6 marks. But if you didn't submit this, trust me, you will not pass this module. This is mandatory requirement from BCS accreditation. Guys, make sure so everyone don't forget to submit any one of these. Yeah. The ethical part is all about the 5 minutes presentation. If anybody missed it or failed it, or if submitted more than 1 week beyond the deadline, so you will be definitely failed. One attempt will be wasted. So please don't do like this way. And this is an individual submission. Make sure this is not group submission. Later on, students, they are saying, we thought the group coursework is group-based, and we thought this is again a group coursework. So please make sure first one is an individual. If you can check it here, the class test is again individual. And last coursework, maybe not class, but maybe we'll take it like, week 9 or week 10, something like this, but make sure there will be 4 to 5 is the maximum right now, according to BCS currently. We are going under accreditation now. If there is any special cases, let me know. I'll let you know. Maybe you are unable to find groups, so I would say please start finishing your group members now. Maybe I will come to teach you on campus, so please make sure you should have groups to practice everything on the time. Okay, everyone. So please, final reminder, ethical presentation is 5 minutes with submission with PPT record. I will show you something. So please make sure this must be individual. Class test must be individual. So we will let you know. Before classes, do you guys want a mock test? If you want a mock test, let me know. I can prepare something before the real test. If anyone can let you know, do you want a mock practice test before real test?
Yes, sir, that will be helpful.
Yes,
So,
sir.
so okay,
Yes,
so that's
sir.
so what I will do before a 1 week of reminder. Oh, sorry, no reminder. What did it say? Yeah, okay, maybe before 1 week or maybe 3 days before the real deadline. So what I will do, I will create a very simple mock test for all of you. Make sure you are aware of the technologies, how to submit. And I have seen the student, they are not able to submit class test sometimes. Maybe I don't know. Sometimes they are using poor internet, maybe away from the home, but they are walking around, traveling around. So they are submitting their class test. So this will not be case. You will lose that time. Please make sure you should have a solid internet. Make sure you must submit this from your laptop, and this is online based class. But make sure you must be with solid internet, please, at home. Yeah. If you are 1 minute late beyond the deadline, so what will happen? If I say your deadline is from 11 o'clock, 11 to 12. So make sure this must be on the time. 1 minute late will be more than troubles. Yeah. So might be I can say this must be 14 minutes, 11 to 11:45 on Ulaya. So if you didn't submit within 45 minutes, 46 minutes will pass, then you will not be able to submit it. This will be problem. So please do it accordingly. Yeah? First two parts and last one will be group coursework. So you need to start it. This is heaviest weight for submission. So definitely there is lots of work you need to do all continuously, contribution, check the rubric, check the breakdown, how you are going to process this report. So I will show you some sample definitely later on. So this submission will be made here. Right now you think Raja has not done anything, but don't worry. So, but we have already discussed the deadline. So you have to be very careful. The deadlines is everywhere. Okay, guys, so I clearly mentioned, so you need to be very responsible right now. So be very active and proactive. Let's start. We will answer all of the questions later on. All the lectures will be available from the ULA. So please go ahead and download from there. Sometime I'm changing a little bit. Sometime, I'm using exactly the same thing. So you don't need to worry about all these things. Yeah. Okay, guys. So today we are going to cover the application layer. So make sure we are going to cover, as we said before, we will cover the different protocols layer. Right now in business data communication network, we are going to cover only on application layer. So what does application means overall in communication, in networking, in terms of businesses? So it should be not too technical. This should not be too simple. So be very active. So might, there will be plenty question comes across your class test. So quick question and quick recommendation for all of you. If you would like to get good marks in class tests, as I discussed with you, please make sure you need to listen to the lecture every day very well, every week. Yeah? So what I'm telling you here, what I'm showing you here, more likely all question comes from there. Yeah? If you listen it, if you read the slides, trust me, your class test will not be a simple problem. It's very simple then. Yeah. Okay, guys, so application layer. So according to, internet model. So let's say this is internet model, TCP IP model, and we have another OSI, which is bit legacy in all traditional, but still it's under progress. It's working. Yeah. So there are different layers. So application layer, transport layer, network layer, data link layer, physical layer. There are just 5 layers only. But if we say here in OSI model, so we have plenty layers application is on the top, presentation, session, transport, network, data, and physical, all these link layer. So today we are going to cover the top of the level. We say, the layer number 7. We will cover this as well, but right now we are going this direction. Okay, guys, so please make sure what is shown here. So we will discuss everything. We are not going to do this thing, not going to do this thing. But again, everything is interconnected. Once we cover this thing, make sure this is already connected. If we cover this thing, transport or network layer, make sure they are interconnected. Now we are learning on the application layer. So overall, we say application is all about the software. We say it's a top level software. We say your user experiences, user interactions are designed. If I can show you what is mentioned here, there is a guide, there is a user, we can say. There is a laptop screen, and there is some kind of browser. Maybe, WhatsApp, ULA application, Microsoft Teams, something like this. So these are all, categories. We know these are the software. If I click anything, Firefox is a browser. Again, this is known as a software. If I click in Outlook application, this is the installed native application. I can say this is again an application. We say that everything what we are using on our browser thing on our laptop screen, the visual part, the top level parts is known as the applications. Yeah, all applications. So whatever we are consuming and using, these are known as application layers. Okay, so how they are working. So normally applications are the software, the apps. So they are trying us to enable to interact with the networking and perform plenty tasks. You know, if I'm typing something like here, let's say. So might, you might be not aware, like if I'm saying youtube.com, maybe, bbc.com, something like this. So if I hit this, URL, something like this. So this is just, interaction. We are going to interact something here. bbc.co.uk. We enter some kind of, domain name here. So something like this. So what's going to be happening backside? There are lots of things going to be connected, but we are not aware right now. If you can check. So we just enter bbc.com, something like that. BBC is not available on the browser things, not available on your laptop. It's communicating, it's coming from the internet layers, lots of internet, which you can see that you are connected with the Wi-Fi and you are using multiple layers on the internet. So from physical data network, transport session, presentation, then we are going to consume it to utilize it, something like this. Yeah. So application, they are software, so they are just kind of abstraction. So what they are going to do, let's say you didn't enter any IP addresses, you didn't enter any protocol, you didn't enter any network protocol, you didn't enter any physical addresses, media access links, something like that, and you didn't install any cable right now. Everything is plugged in, cable is plugged in, your internet is working, your routing protocols are working, your security and presentations are already working, but who did it? Yeah. So normally, there are some kind of layers of OSI and TCP IP, so they are going to be happening from next side of your computer. Right now, we just enter bbc.co.uk, but it provides all of the abstraction here. We are not using here. So this guy is going to abstract these things, so it's going to communicate accordingly. So we say abstract is enabling us, providing an intermediate layer. So we don't need to worry about everything. Everything is performed internally of everything, like application layers, all about whatever we are using, like domain name, service, HTTP, file transfer, protocol, HTTP, simple mail transfer, telname, whatever we are using on browser computers, based on these things, these are known as application layer. If I can show you lots of examples, it will take a lot of time, but I can show you, let's say you use something like, can you check this is HTTPS, something like this. Yeah. So there are plenty things you are using. The DNS is there, everything is there. So we know this is application layer simply. So quickly, let's finish the application layers. They have kind of, the different parts as well. Let's say you are using application, maybe browser, bbc.co.uk, something like this. Yeah. But this is not just a one part, they have already categorized in different, presentation. So once we use it, so this is going to present first of all, the first layer, like, presentation layer. If I'm asking what is presentation, so I would say the beautiful thing, the interactive things, these are known as a presentation. Yeah. Simply, if I can show you, let's say you are opening a WhatsApp, anything or any browser. So you will find, click this button, submit this button, input your name, text box, chat box, so all these things. Maybe, there are some buttons. So we say user interferences, user experiences, interaction and experience, all these things, they are known as a presentation, which is visible part. If I can show you from the PowerPoint slide, so I can say this is button, the drop down menu. This is design button. There's enough, drop down repository. There are plenty things. So I can say if I click it, it does work. Yeah. So these are the representation, the presentation. These are the top things, like whatever we can interact, whatever we can experience during our internet communication. So this known as a presentation, the one first thing. Yeah, presentation. Okay, guys. Now after presentation, let's say if I'm clicking, as I say, if I'm clicking this file button, is it working? Yes, definitely it's working. So why it's working? Because after beautiful thing, there is something happening beyond the presentation. So we say there is something logic here. If I click this thing, this will go to hypertext markup thing. Maybe it's really connected with some different logics and data connectivity, all these things. So first one is all about the presentation. The next one is a different logic. If I click this, then another logic will perform. So for the presentation, the logic means the serverless, Java thing, C# thing, the PHP thing, all these things, the different programming language, they are going to perform something. So we know this is logical area. First present, then the logic. Last one, let's say, if I'm going to design something, let's say there are plenty of designs. Who is going to provide lots of design? This is just button, but there are millions of the design, thousands of design from the application. Who is going to produce it? These are already saved somewhere. So in this architecture, we did presentation, logic, and at the end, so I say there is the storage. So all the applications, they are consuming some storage as well. So we said they have some services from the server. Server is giving them storage. So they are everything getting from the storage. So we say this is their permanent storage, something like, data storage. Data can be OLAP and OLTP. So this is different story. I'm not going to tell you. Analytical processing and transactional process, whatever you are going to collect it, either latest data, analytical, transactional, which is very latest one, very important one, and very useful one. Sometimes it's analytical processing. Maybe the one of the more than 10,000, 5,000 months old or days old. So we are using the very old data as kind of an analytical processing. The servers are always storing them based on the TP and AP categories. So these are connected. First application is presentation, the logic, then the storage. So we will cover this again. Don't worry. I hope so. Please make sure there will be some class discussion. So I don't know, students, they are going to be.
Prof, can I ask a question? What's the difference between AP and TP?
Sorry, Ilera, you are asking something. AP and TP.
Yes.
Yeah, TP. Yeah, this is
Yes.
good question.
Okay.
Yeah, I'll let you know. Thank you. Yeah, guys, if you have any questions, so please let me know. Yeah, anytime. Yeah. Okay, so analytical processing is like, is anybody is familiar with like, Power BI or Tableau? If you have used any Power BI, might be, we are consuming lots of, analytical processing.
Yes, I've been working for 3 years with Power BI.
Yes, so Power BI, Tableau, and Orange things. So this is the way, like, so we are going to teach lots of things over there. So analytical processing, let's say we have a data sets. Data.
With DAX, yeah.
Exactly, analytical processing, and we have transactional processing. Transactional processing means, let's say, so you want to perform Power BI, the visual boards, the dashboard, the calculation, the condition.
Yes.
Something like this. So what you need to do, the transactional data is like, this is more important data, like, data coming from your financial sector, maybe, stock exchange data, which is more important. Let's say you are getting data from Barclays. This is all about the transactional data from the, financial hub, something like this. They are categorizing it here. Our servers, they are categorizing. Some data is like more important, which needs more security, more accuracy, more feasibility, more resiliency. So we say this data is transactional categorized, which must be secure, which must have a faster track to process. Sometime, like say UWS is not just 1 year old UWS. Maybe we have more than 30 years record of a student. If you would like to access like more than 30 years old student record, so we say this data must be categorized as an analytical processing. Yeah. So which must be taking a lot of time during processing. Why? Because the storage server, they are keeping as analytical processing, which say this is not useful like transactional. So keep it as less secure. Is not 100% less secure, but this is less secure than this, and less, takes lots of time to reach for processing all this. This is all about the difference. Transactional is more secure, more reliable, more faster. This is all about, historic data, one of the legacy, oldest one, something like this. Yeah. So we are going to categorize something like this in the server. Yeah. I think, Lara, is this clear? Yeah, hope clear.
Yes, you're very clear. Thank you.
Thank you so much. Yeah. So let me clear. Okay, guys, so please make sure whatever we are discussing, this must be coming into your class test as well. So this might be really helpful. If you are going to submit your class test, please be very active. So there will be lots of questions. Don't know, there is some voice coming. If you can. Shahzeb, your microphone is. Shahzeb, can you turn off your microphone, please? Yeah? don't know. Where is Shazeb? Okay, let me take your second attendance. This is a good. First is done, now second is done. Please, Ratna, turn off your microphone, please. Yeah? Some students there don't listen, they just turn on the PC, something like that. Oh my God. So please try to turn off and I will answer your question. Please let me finish, then I will come. Sorry, Chanzeb, Shazeb. And please turn off your microphone. Yes, please.
Excuse me, sir.
Yeah.
I'm asking you, will be the class test based on the MCQs?
Yeah, class test, before it was supposed to be, MCQs and the short question, also long question before. Yeah. But right now, according to the changes of environment, so we are taking everything online with MCQs. Yeah.
So it means it will be on MCQ base.
Yeah, should be MCQs. Yeah.
Okay, sir. Thank you.
No problem. Yeah.
I want to just clear that I'm all right about attendance.
Yeah, attendance is already done, so you don't need to worry. Yes, so I'm taking from online lecture. Yeah.
I didn't log in from my banner's ID, that's why I was just asking.
Yeah, don't worry. So it should be recorded there. Yeah. But make sure you need to log in, please. Yeah. Okay, guys, let me finish. So I will answer your question. Let me finish. Thank you. Don't worry, attendance is going to be happen every time. I'm taking it. Don't worry about it. Yeah. And please try to turn off your microphone. If I will mute it, so what will happen? I don't like it. So maybe you have question to ask, so trust me, it should be kind of recorded version. So I would say try to give students to learn something. If I mute it, so maybe you are not reaching me well. So please, if you're not listening, I know you will face problem. So this will be, I would say, if you listen us, trust me, you will get rewards very soon. So you will get good results. You need to know what we are going to do. So please, you are here for study. Listen carefully and try to mute it. So everybody's here to learn something. Yeah? They want to pass modules with high flying colors, like, not just pass 50, 60. I wish everybody will get more than distinction, but please be very proactive. Yeah? Thank you. So let me finish, then we are coming. Don't worry, everything I will make super easy for all of you. So thank you. So let's say there are some architecture. We say host-based architecture. Let's say what are the host-based architecture? Simply, host is all about, if you nearly know anything about the host-based, host is all about, maybe you use something like, VMware Oracle virtual machine. So let's say you are installing, this is your physical machine and you are installing a VMware inside your laptop. So what does VMware is doing? Inside VMware, you can install different operating system 1, operating system 2. Maybe you can install here Kali Linux, you can install here Ubuntu. Maybe you can install another thing like, let's say you're installing Windows 98, the one of the oldest Windows. So we created the 3 instances. Instances mean the virtual instances inside the VMware software. But this is just host. So this is a host base. So this is giving the one physical host, another physical host, virtual host, and third one another host. So we say these are the host-based architecture. Why? Because just one PC or one laptop, one Core i5, Core i7 can support more than three virtual machines operating systems. So why? Because this is host based. Host is doing all these things here. So let's say it has 16 GB of RAM, dynamic DDRM4. So what it will do, it will random 3 here, 3 here, 3 here, and it will use it for itself. Maybe 5 to 6 gigabytes of the RAM. It's just sharing the physical location. That's why we say it's a host based architecture. So in the client server application, if we are creating a host-based architecture, so let's check it. The presentation, we did it, and the data things, and we did it, and logical things, we did it. The presentation, the logic, and storage, everything, server is performing. Yeah. Let's say once we are creating any host, so we say this is our main machine, so this is performing everything for them. But if it's client server architecture, the server is doing everything. Logical things, presentation thing. The PCs is not doing anything. Did you see anything? Have you seen this? Let's say you are going to any reception with NHS staff, maybe NHS, any hospital in United Kingdom. They have very small PC near to desk, something this is connected to the screen, backside of the screen. So very small PC, less than something similar to the mobile phone. So this is connected with them. So they are using the host-based architecture. Why? Because the NHS staff, there is no technical guy, there is no IT guy. They are not going to manage. They are not going to waste the time. They would like to use host-based architecture where the server is doing everything. All these things, security, presentation, everything. Someone is doing remotely for them. Yeah. So this is very small, and this is very small and very slower in processing, but this is managed thing that we say the thin client, which is always used at one of the biggest company in United Kingdom. Let's say NHS is using it. They don't keep a big larger desktop like GPU, CPU needs to be maintained. All these things university is not using because they need powerful thing. NHS is using thing. So we say thin clients they are the powerful example of host-based architecture where server is connected remotely. So the server is doing everything for them. Presentation things, logical things, the data thing they are doing remotely. If there's any security issue concern, they are going to do and manage remotely all these things. Yeah. So we say this one server is performing this thing. So true or false, it's host-based architecture, then you need to say true because this might be a question in class. So please make sure maybe sometime Google is not answering this question. So you need to learn from slides. All this will be really helpful. Yeah. Host-based architecture is one of very simple, as I say, and this has a single point of control. Somebody can control remotely, like keep a one guy to keep a security for all NHS hospital. Keep one guy to install the networking thing. They remotely can install all networking because of single point of control. It's very simple, but there's some might be disadvantages as well, and they are easy to target, like malicious activities, middle attack. Someone can destroy it, like DDoS attack, something like this. Why? Because if there's single point, let's say there are more than 15, maybe 100 PC, they are connected. One is here, one is here, one is here. The connection is all about the internet. If someone is breached this thing, so everything, all the hospital will be under attack. Something like this. Like our university was under attack like 2 years before, because we were using centralized approach, single point of control. Somebody attacked us, so we were under attack, something like so. This can be bottleneck as well. So please make sure there is some advantages, there are disadvantages as well. Again, this host base and client base is almost similar, but the difference is like the thin client, while like your server is doing everything, our virtual instance like we did it here. In client-based architecture, this is a little bit different. Like the server has little control and the client has little more control. Client content, presentation, and data, and server contain only the logical thing. That's it. Yeah. If we give everything logical things to the server, we say this is client. If we give everything to the server, then we say this is the host, basically, and more like thick clients. So if I'm asking a question, what are the thick clients? Anybody can let me know. Like thin client, I told smaller PC, simply you can see it. If I'm asking what are the thick client, please. Fat client or thick client. So thick client, fat client. Can you see the laptop, the one I'm using, the laptop you are using? So these are known as like thick client machine. We say personal computer, the workstation, whatever you are using. These are all about the client architecture machine. So you are using client-based architecture. You are not 100% relying on server, but again, some logic, some data is coming from the server. Say we are more likely client-based architecture is the kind of a client-based. Yeah. What are the advantages, disadvantages? Again, these are less expensive and this is simple architecture, but you need to maintain individually. Client-based, they need to be maintained individually. Why? Because these are separate machines, so individual machine belongings to personals perform computing, so they might be performed individually, manage individually. This is only disadvantage as well. It takes time, but they are very easy to manage, very less expensive, something like this. Yeah.
Thick client, it's like a data warehouse. Instead, thin client can be a Gmail in browser, or am I wrong?
Yeah, thin clients mean, let's say, have you seen the very
Gmail?
Email is kind of thing. Maybe you can say Microsoft Outlook can be a special thin client, something like this. Yeah.
Okay. What about the client? It's like maybe it's similar like a data warehouse.
Wait का क्यों बोला था?
No, thick clients means the machines we are
वेट का
using.
क्यों बोला था?
Excuse
Okay.
me, can you check the simple PC? This is one of the very simple PC. This is Dell thin client. So if you, this is like, you know, little bit larger than your mobile phone. These are
वेट
PC.
का क्यों बोला था?
Excuse me, could you please mute your microphone? Who is speaking? Sayed Zen? No, it's something different. I think. Sorry, I can't check. My laptop is very tiny. Mohammed, please. I don't know. Sorry, my laptop. Please try to mute your phone. Sorry, Ilara, let me clear it. Yeah. So Dell Wise machine, you know, these are one of the tiniest machines. So if you find it on the Google, something like that, maybe, you know, eBay or Amazon. So what does it mean? Thin client. So these are the PC physical, you know, if you find it, it looks like a PC. They have port USB port 3 as well. They have like, you know, port A for USB communication, but they're more like the, you know, they don't have any graphical processing more powerfully. They don't have anything like, you know, GPU or high power processing. They are very, you know, simple, like, you know, small index processing things, like, you know, it's like mobile platform, very mobile platform. They're only working on the internet connectivity. Once we give them internet, then they are capable to use the remote. Like you said, Gmail is a thin client, definitely, then Gmail will work clearly. But they need some physical thin client. You are correct. Yeah. Do you know any Chromebook? Like, you know, this is Chromebook. Chromebook is also example of thin clients.
Yes.
So if you give internet, the Chromebook definitely work. If you are not giving access of internet, definitely it will not work, because, you know, thin clients are reliable on the server.
It's very clear. Thanks.
So all the Google thing, Microsoft application, once they are, but again, we say thin clients are physical thing. They are dependent on
Sorry
more
if
like
I'm interrupting you all the time, but
no, this is good. So at least systems they need to learn, like you are actively working, you need to know. This is very good question. So thank you, Lara. Okay, so this is good to ask, please, everybody. And if you want to discuss something more networking thing, once you have any coursework ready, so please let me know. I will come down to campus. We'll work together. I will let you know proper packet tracing if you really want to work. So I will let you know all these simulations thing. Yeah. So let's finish it. So thin clients, all the done now. So let's talk about what are the clients actually. The client is, who is the client? It's not a client like if you are buying something from Amazon. Client is not something like you're buying. Client mean definitely, you know, the meaning is simple and similar. Clients mean the consumer, the user. Clients can consume any service, but sometimes, you know, clients are not consuming. Clients, they are not consuming at all. So if I'm asking, is a programmer client or no? Anybody can let me know. Clients, like, you know, you are using Google Chrome, so you are consuming some resources. YouTube.com, you ask YouTube to render some
maybe yes.
Yes, we are right. Exactly. If you are a developer, you are creating APIs, like, you know, you are creating security patches for, you know, the server side. Let me show you. Sorry, this is my personal drawing. Sometime I'm using, let's say these are the servers. So servers are not working as it is. So let's say we have a programmer. So they are going to create something with the internet, with the command line interface. They are going to communicate the servers, the rack server, the physical server, the tower server, the blade server. So clients are also sending lots of information, creating the servers to work very well. So if you use anything from server, we known as a client. If you can produce any programming thing, configuring any server, again, we say we are again a client. So make sure client is any person, like, you know, any programmer, any user. If you use Google, no problem, you are called as a client. If you put something like post things, put things, delete things from kind of, you know, Java servlets, maybe PHP, C Sharp, cascading style, all these things, they might, you know, the HTTP GET and post might be work in future project. So these are again known as a client, you know. So mobile phone is a client, again, we say. Any browser is known as a client, so you can do from whatever you. So this is all about the client. Okay, guys. And what are the servers? Maybe this is sometimes student, they say server might be, you know, these are the computers larger than the buildings. I can say yes and no. There is some kind of logic, you know. The servers are again the same PC, like, you know. If I can show you something here, let me tell you. Let's say, sorry, sometime I'm not doing any, you know, motherboard socket. let's go and get anything like 1151 socket motherboard. Let's say if I'm opening here any, sorry, I don't know where we are. I need clear picture. Okay, if I'm opening, this is a motherboard, kind of, your desktop PC, but you are using laptop. Again, laptop is the same motherboard, but very, very similar scale. The scale is very small. CPU is a very, very larger here, but in laptop thing, so this is will be very, very similar one, soldered one. Yeah. So depends, like again, we say motherboard is similar for everyone. Yeah. So they have a ports, they have like, this random slots, like we can say, the virtual RAM. So we say this is a RAM slot, this is, CPU central processing unit. There are some kind of, the peripheral interfaces, this is graphical interfaces, all these things. There is some power supply connection. This is all about, USB port. This is all about, internet connectivity and USB-C port. This is audio and maybe something different. These are the different, the button. So there is different thing, like logical thing, mathematical thing, all the physical thing, virtual thing. So this is all about the motherboard. If you open it, yeah. So if I'm asking, this is your PC, you are using a desktop PC or laptop PC. This has just one CPU, and this has just might be 4 slots for the RAM. Sometimes your PC is using maybe 2 different RAM channel, 8 GB here, 8 GB here. Sometimes you are using 888, 32 gigabytes. That's it. Yeah. 32 gigabytes, and maybe you are using just Core i7 PC 12th generations Intel Xeon, maybe something different processor. So what does a server is doing? Server is the same motherboard, no difference at all. The difference, like they have the redundancy. This your PC is using one CPU, the server might be using 2 CPUs at a time. Maybe server motherboard. If we go to open server motherboard, maybe we can open PowerEdge server from the Dell. Let's say I'm just opening randomly, just so don't worry, I'm not branding, supporting any brand. Dell PowerEdge server board. Let's open it. Yeah. If I can open it clearly, like this is a tower server. If you can check it, this is not worked with Intel, normal Intel processor. Like we say Core i5, Core i7, the server is using again from Intel, but the Intel processor is different. We say a Xeon processor from Intel. So why Xeon? Because Xeon are designed for the server processing, and server means so they are running 24 hours, all the years, all the months, all the minutes, they are working simultaneously without any problem. And why there are 2 processors? Let's say if one processor is working 24 hours within a month, definitely it will get hot a lot. Maybe it can be damaged, but Xeon is more reliable, durable. But if it's damaged, no problem. Server is using redundancy here. If one is down, the other will definitely work automatically. If one is down, this will work. But if you are working the Asus board from the socket 1151, if this is dead, if one problem occurs, so this will not working at all. That's the difference. We pay less for the desktop boards, but we pay huge money for the server board, something like this. Why? Because they have dual things, like everything is dual. The RAM channels are dual. If we connect a power supply, they must be dual. If one power supply is down, so there will be another power supply work with redundancy. If one CPU is breaking down, the other PC will work it here. If the any channel of RAM is broken, not working, so this will work again. So this means server is a redundancy. But again, they have the same architecture, the same process, the same brand, nothing different. So why we say the server is more powerful? Because servers are working 24 hours. They are in the different form. Maybe the blood server, maybe the rack server, maybe the tower server. The one motherboard I showed you, it was something from the tower board like this way. If you want to do any work on server, so this is the way you can buy HP Proliant or Dell PowerEdge. So they are the one of the best tower producer. Otherwise, if you want to go like data center, the one of the Google data center, Microsoft data center, they are using the blade and like rack things, something that is more than the building. So they are working thousands of blade server. They are interconnected and they are working 24 hours all the year. So we say the all web server, all application, they comes across from all the servers available from their data warehouses. So that's why we say server provides services. Let's say you watch your video, 4K videos, this comes from the server every time. Let's say you are communicating with your family members on WhatsApp. Every time your family member is sending 1 GB of video, 4 GB of video, you are sharing, they are sharing. So your all data is going to be shared with any hardware servers of the WhatsApp server. WhatsApp has lots of server, they are going to store your data. Yeah. Otherwise, this cannot.
Can I
Yes,
ask another question?
yeah,
Sorry
please. No
for
problem.
making so. About virtual servers, can be public and private or only publics?
Virtual servers, it depends. Can be public, can be private. Yeah.
It depends on cost. I mean,
Yeah.
public servers are cheaper than private servers, or it
Yeah,
doesn't.
exactly. Public servers are cheaper than private because, if you would like to keep them private with kind of, encryption, decryption, insecure encapsulation, IP security, like different VPN protection. So we say this is privately for you. Let's say UWS is using ULA virtual learning right now. So we have kept it private so no one can access.
Okay.
Let's say if I'm emailing you, all of you, like, thousands to London and Paisley campus. So definitely, I will not publicly email all of you. So everybody can check with each other. If Ilara, you will reply to me, what will happen? So other students, they will not find your reply back.
So it's a private.
Should be private because we are paying something extra money to keep them private. Yeah, we are communicating with our students. But public servers means which is for really accessible for all of you. Yeah. If I'm asking, let's say this is our mass community. So right now I have created it. Yeah, so definitely. So we know this is a simple example of public access. So anyone is messaging, so you can find if I'm sharing anyone, so everybody will get this is publicly available. Yeah, publicly or globally. That's it. And privates are very expensive. This is again good question. So server can be on physical things, server can be on virtual things like, type 1 hypervisor, the physical hypervisor. If let's say Oracle, VMware ESXi. If you get anything from the virtualized server, you can get, let's say you want to get a server. Maybe you can say, sorry, I want to go with Amazon Web Services. So they will produce. If you want to go with Oracle services, they will do it here. If you want to get it from Microsoft Hyper-V, they can do it as well. There are lots of things here. If you want like physical server from, Cisco proprietary, so you say, I need a server, I want to store my student data over there. So what my Cisco will do, Cisco will create its own server, bare metal server, maybe 50 server, maybe 20 server, then they will give a connectivity remotely to you to just to access login, all this you can perform, you can store what you want. It depends. If you wish, you can create a server near to your premises as well, like UWS can produce it, create it, but it's cost a lot. Yeah, it takes a lot of time. Lots of management. It's better to waste like third parties rather than doing it natively installation deployment. That's why servers are always the on demand service. So we will discuss this in cloud computing later on. I hope this is all clear. So let's move forward. And that's the server. So hopefully it's all clear. Now client server architecture. We say this is client, we say this is server. Simply, I can tell, I can teach this more than the few hours in real detail, but this, I know there are some non-IT students. So I'm sorry, I'm just going it very, very simple. At least you need to know, and make sure right side, there are plenty of things because, this lectures, these slides, sometimes I'm using at different courses as well. I'm not just teaching IT, I'm sometimes, teaching Paisley campuses, sometimes different campuses as well. So I'm delivering some lectures as well. So that's why I'm just preparing the same slide I'm using everywhere. So that's why, so you don't need to, learning object. Definitely these are related to your lectures, all these things, but sometimes they might be a little bit different as well. Sublime Editor, Visual Studio, HTML, all these things. And I know you are not going to work with Sublime Editor, not going to produce any web architecture or server things. So don't worry, this is just a concern related thing. So you need to know if you really want to know. So make sure these are the same thing connected, right side, left side. Let's talk about the client server web architecture. If I'm say, as we say very, very clearly, we are the client. Like you are using WhatsApp, you are using Google, you are using laptop with ULA virtual services, ULA virtual learning environment, and you are connected with internet, maybe Wi-Fi, maybe direct RG45 thing, no problem. And you are connected with what? You are connected like you are using a one internet line from here, and normally once you connected with internet, we say internet service provider. So this line is going to go directly from this server, and this server, but there is some order. This like this. Let's say if any student is typing like let's say bbc.co.uk. bbc.co.uk. So what will happen? So client from the browser, he wanted to request hypertext transfer protocol request. So we say the HTTP request is sent over from client to here. Now request is not going to BBC server. Let's say so you are watching YouTube, youtube.com. You say http.youtube.com. So you are going to watch a YouTube video, 4K video. Now you are not going to get directly from here to here. This is wrong. Like, you know, the data is not coming from the YouTube server. So what will happen? The YouTube HTTP request, first of all, will go to the web server. So where JavaScript, the PHP, they are going to communicate with the client. Sorry, let me turn off my microphone. Okay. So this request is going to be pass through the web server. So web server is the first server which is going to communicate with the client. Client is communicating with web server. Maybe I will ask same question from the class. Now web server will search like, okay, this guy needs BBC, this guy needs, another guy needs YouTube. So what will happen? The web server will send request to application layer. So application layer, what it will do? Application will say based on the request location, the geotag, all these things, the security. Let's say someone say I want to check BBC News. Someone say I want to watch YouTube. So application layer say, oh, okay, YouTube is a UDP payload. So they say, okay, this guy needs a UDP payload. So the from the YouTube database, that data is going to be through application, and then UTB packets are going through again, like, you know, the same AISP. This is going back to the YouTube listener who wants to say, if you want to check BBC, so comes from web server to application. Application say, okay, this is TCP connection oriented. It will apply some security protection. It will render things. Let's say you want a UDP. Okay, this say once you are going to render it, it say okay UDP, so there's no security directly, you need 4K reduce. It say okay, this is heavy payload, we don't need more security, it should be connectionless, so it will reach to your browser quickly, so your internet can support 4K video. If they apply security, you cannot watch 4K videos. Let's say somebody is watching on mobile phone, sometimes you are watching on 100 inches bigger TV. So what will happen? So that this, you know, the web server will apply or render different cascading style from the HTTP. These are things, visual editors, all these things, the whatever the backend encoding was designed. If you want to watch 7-inch screens, it will reduce the resolution. If you want to watch on 100-inch, it will change the cascading, the padding, all these things, texting, everything will be changed. This will be rendered to the different lines here. It depends. So that's why, you know, these are the different servers. They are working randomly, dynamically here. So like same video you are watching on the mobile phone, it will be 70. Same video you are watching on 100-inch TV, it will be rendered in multiple instances, multiple, you know, direction configuration. So that's why the configuration is all about like this. You know, request was gone through this way, request is passed through this way from this thing. Directly this server is not sending to you. It will send you from here to here, then it will send you back from here like this way. Again, now web server will apply the, oh, this guy need 100-inch, or this guy needs just 7. So this will render different cascading, padding, all these things. So there are some configuration. That's why whenever you're creating a web page with Sublime Editor, HTML, so you are going to create this thing, the dynamic configuration. So that's why you are going to get it properly. So this is just architecture. I'm not going to go into it technically, just at least you need to know how the 7-inch screen, how the 100-inch screens are getting 4K videos without any troubles and buffering issues here. Okay, guys, so client server architecture, we say very easily, we say these are the very easy. I think clients are more functional, like, you know what, PCs are thick clients. Thin clients, like we said, they work with like Google Chrome book, something like this. Yeah, this is all about like if you find it, so you can find it from Google. Your Dell machine, your HP things, so these are all about the whatever you're using, Asus things, XPS things, Dell Precision things. These are all known as a thick client or thick fat client. So I hope so. Let's go ahead. What are the advantages? Very easy. Client server architectures, definitely we need it. Otherwise, we can't produce like, you know, distributed and feasible thing and processing. That's why we are using it. Yeah. If I'm using I'm delivering lectures. Why? Because of client server architecture. We are using their application layer today. Otherwise, we can't do it, And what are the disadvantages? So they may be expensive. We need a lot of hardware and software. Exactly, we need it. Otherwise, I can't reach you with ULA things, all these things. So these are the disadvantages because configuration is challenging. The power is very expensive. But again, the client server is very, very beneficial for all of us. Without this, the internet connectivity is not possible. Okay, so there will be every advantage, there will be some disadvantages there. Client server always need, middleware sometime. Let's say you are a client, so you are using Google Chrome, no problem. You can use sometime, maybe some students, sorry, I will use the Firefox browser. Can you check? This is Opera, this is Google Chrome, this is Internet Information Server, different browser you are using. And server and YouTube is not just based on Cisco thing. Maybe the YouTube is another server with HP, Juniper as well. Juniper, Cisco. So this server is different, this server is different. So what will happen? So, these companies, they are also using the middleware. If they are using Juniper, so the middleware will convert these things to compatible with the client's Google Chrome. If the YouTube is using Cisco databases server, so what will happen? The middleware will convert the middleware, then it will reach to the Firefox. So we have a middleware which convert and make a compatibility possible. Otherwise, it should not be possible. Because in internet, in networking, there is not just Cisco, there is not just Microsoft. There are millions of that databases, server. They work with different proprietary things. Maybe some Cisco, maybe some Microsoft, some from Dell, some from HP, but they are everything different. If you buy Cisco server, you have to configure with Cisco program. If you buy Juniper server, you have to configure with different Juniper coding and configuration. They are completely different. That's why middleware means which just translate these, convert them as a compatible thing. Yeah. Let's say if someone is speak with me French, so maybe I don't understand French. So what I will do, I will use this translator. Translators can convert as a middleware thing for me. Yeah. Okay, guys. So networking does have all these things which manage and make configuration compatible. Yeah. Let me finish. So 1 hour is going to reach, then I will ask you a question, then we will finish it there. So major type of client server architecture. Again, this is very basic way. I will let you know there are different types. If I say 3-tier architecture, application 3-tier architecture. One is 3-tier, other one is 2-tier.
Can you please zoom in a little bit more?
Yeah, sorry, I'm not running, but let's show it. So if you check, this is 3-tier architecture. So right now, maybe I can't write, so just I will use arrow. 3-tier architecture. So let's say why we say 3-tier architecture. Again, it's the same thing. We are going to create a client server with this architecture, separate, we say loosely coupled things like, let's say presentation is working independently here, the application is working independently here, and our data or storage is working independently. Let's say you are working with JavaScript, HTML for client. So we say presentation was made with this thing, but you have to make it different server. So you have to create all these things, you have to deploy all these things, but make sure that tier will be different, individual, nobody's affecting. So all the presentation configuration coding must be on the separate server. Then you are going to create another logical thing like, the web services, and you need another server. So what you are going to do it, all the services you are going to create on different tiers. So we said this is different layer. Create presentation separately, create logical services on different things. So we said number 2 tier, and you need to create a database, SQL database, maybe whatever you are going to use it. So make sure you are going to do database on the separate layer. So we said 3-tier architecture. So this is all about. If we get an example, like, one of the biggest server, let's say SQL server, Internet Information, MongoDB, Zen server, Amazon Web Server, maybe Zen server, maybe the Oracle Oracle things and VMware ESXi. They are always designed because they have a lot of power, lots of forces. They can deploy, they can configure, they can pay a lot of money. All that's why they are using different individually. They need to separate because they have money. They want more power and performance. Yeah. So we say they are distributing it separately. We say this is 3-tier architecture. There may be a class question. If I'm asking the Amazon Web Server is a part of 3-tier architecture or 2-tier architecture. So you need to select. So 3-tier architecture will be your correct answer. If you say both, then you will be wrong. So please make sure Amazon Web Service is a powerful service provider. So this must be 3-tier architecture. Yeah. Okay, guys, simply, so we are not going to design any server, but this is just simple. If it's say 2-tier architecture, sometime you are working, on local projects. Let's say you want to deploy something, maybe, security thing, maybe, web services, maybe you are using Apache, maybe Zen server, so it's possible. So what is 2-tier? If you can check, application and data, we are going to merge just in one server. We need to purchase one server and we need to use services and database inside just one server. So we don't need third server here. Presentation, they are just, 2 lines things. So you need to compare them, complete them, and you need to create these things, application data altogether. We said this is 2-tier architecture. LAMP, XAMPP, Apache. So these are the XAMPP server is again, sometimes using both configuration 2 and 3rd as well. If I'm asking Zen server like this guy, Zen server is a part of 2-tier and 3-tier. True or false, you need to say true because it is a part of both things. So please make sure you have to be careful. And let's say if you are going very, very cheaper working platform, you want to create something very, very cheaper with local hosts, like, maybe more private. Nobody can access it's just local, nothing to worry about, no internet can access it. So what you need to do, then you need to go again a XAMPP server, like the same thing is a part of tier 2, tier 3 and tier 1 as well. You can make it possible. This is open source. And local host, anything, let's say you are going to do everything, the presentation, the application and the storage, everything inside one machine. So we say this is a tier 1 architecture. Let's say anybody has you used before, like VMware Oracle VirtualBox. If we are using VMware virtual machine, if you are using Oracle VirtualBox, so this means so you are going to create a local host on your local PC. So this is a part of your, this 1-tier architecture. So you are going to do everything inside your same machine. So maybe in future you are going to do a project. So make sure you are going to do this will be the easiest way for all of you. Install VMware player, install Oracle VirtualBox, and you can play with all these things inside the same machine. Definitely it will work. Yeah. Tiered client architectures is why we are doing clear tier things. It's very simple. If you have money and you want more powerful things, so definitely that these things work smoothly, buttery smooth. There will not be any obstacle. The security implementation will be easy. The performance will be easy. Directly you can get the trillions of the data, the gigabytes and big data directly, because the tiered are separately coupled, work with each other. So that's why load balancing is one of the easiest way. If you are tight loosely coupled, nothing is dependent to you, so you can easily load them and it's more scalable. You can use from America to Europe to America. If you are using 1-tier, this is just locally available. You can use from your one machine to another machine within a house or local area. You can't do it with metro and the publicly available things, something like so. That's why we see load balancing is one of the big advantage. And disadvantages, if you are increasing tiers, you need to spend a lot of stuff to manage, lots of money and lots of configuration. This is one of the difficult thing. If it's locally one machine, one student can develop, it's very easy, but this is not powerful, something like 3-tier architecture. This is all about the overview. I hope so you got
Sorry,
it now.
sir, to interrupt you.
Yeah.
So my question is Zen server and VMware and or Oracle server are the examples of both like 1st tier, 2-tier architecture, or only 1st-tier architecture?
Yes, VMware. So you can, like, in VMware, you can create host machine. If you are going to create host machine inside, just let's say you created one virtual machine and you'd say, okay, the services will be there, the database will be there. In VMware, you can do 1-tier, definitely. If in VMware you want to say, okay, no, I want to separate it, but you can do in VMware has a power to do it as well. Yeah. It was just example. Any host-based machine is normally a 1-tier architecture. Normally, VMware is assumed to be 1-tier. Yeah. And let me show you this. XAMPP server is a part of, simply you can use every time, like tier 1 and tier 2. Yeah. So you can install it. So XAMPP can work locally. XAMPP can work with 2-tier as well. Definitely work 1-tier, 2-tier. And it's also working with tier 3 as well. Yeah.
So
Because
in question, sir, if you asking in a question like exam server is the example of first tier, two tier, three tier, and the suppose fourth option is like everyone is correct. So might be first and two and three both are everything is correct, right?
yeah, for XAMPP, if I will ask, the XAMPP server is capable to work tier 2, tier 3, and tier 1. So yes or no, you have to say yes, then should be okay. Because I have
Okay.
mentioned XAMPP everywhere. If I'm
Okay.
asking other than this, let's say this is like, Apache, can you check this? Can be Apache again? You can make it like, but don't worry. This is maybe sometime I'm making some error, copying, pasting. But make sure if more likely I will ask the local host, any server designed on host, local host, something like, VMware or XAMPP server. So then you have to say, okay, local host is kind of, tier 1. Definitely you can't say local host tier 3 architecture. I say this is local host is tier 1 or tier 3. So you say this is local host is tier 1. That's it. Should be simple class day. Just follow the slides. Everything will be super easy. Yeah? So
Thank you, sir.
everything. So please make sure the first few lectures, let's say whatever I'm taking, your first lecture 7 to 8. So there will be lots of questions coming from the first lecture. If you want first lecture, second lecture, third lecture, there will be more questions coming from these lectures. If we finish like, week number 9 and 10, maybe there will be one question, probably maybe not any question from week number 10. So I'm just telling you, yeah. But make sure the first lectures are more important. So you need to be very, very careful. Yeah. Especially
So
week
please,
2. Sorry.
hello, sir. Please, can you elaborate? Can you help me throw light on a physical virtual server, please? I'm just a little confused. Physical
Sorry,
virtual.
which virtual server?
Yes,
Yeah.
Physical to virtual server, please. Can you just throw a little light on it, please?
Yeah. Virtual servers, like, virtual servers means, so these are like, try to install VMware and Oracle virtual machine. Like Oracle virtual machine is a software and virtual VMware is another software. We say these are the hypervisor. Not physical hypervisor, but they are type 2 hypervisor. So what you need to do, download VMware player, which is free for you just for a few months. And if you would like to use Oracle VirtualBox, this is free for you for entire life. So these are the hypervisor bare metal 2. Yeah. So inside your PC, you need to install these tools. So then you are able to create a local host, like you can create a virtual server inside there. Yeah. Maybe in future you are working with DOS detection, malware detection, phishing detection. You want to create a log alerts with virtual machine. Definitely, I would not suggest to buy physical server. So I would say go ahead and install VMware, install Oracle Box, create server locally inside your PC, so you can do some master's final project as well. So we will discuss this later on definitely. Yeah. So this can be installed with these two tools here, Oracle and VMware. That will help you a lot. Let me finish this quickly. I hope this will help. Peer-to-peer architecture. Maybe, one of your legacy, or I'm not sure because you might be, have used this before or no, uTorrent and BitTorrent. Maybe you have used it BitTorrent. Maybe 10 to 15 years before you were using uTorrent and BitTorrent, especially people from Africa, India, Pakistan, Bangladesh, maybe from Europe. So they were using, uTorrent and BitTorrent just to download, 4 gigabytes of software. Maybe you are downloading 4 gigabytes of software using uTorrent, maybe using bittorrent.com, uTorrent.com. So why we were using, because 15 years before, our internet was very, very slow. It was taking 4 GB was taking nearly 2 days to finish the download. Let's say you wanted to download American Microsoft from the server. So uTorrent was taking 2 months to download in Central Asia, East Asia, somewhere. So it takes 2 days. Yeah. If anyone is going to use near to Asia, like, someone downloaded from India or Pakistan, if someone is downloading again the same software. So it took 2 days. Now your neighbor is going to download the same office with 4 GB. It will just take maybe 30 minutes. First it took 3 days, now 30 minutes. Why? Because peer-to-peer architecture means first it was coming from American server to reach, latency, the breakthrough. There were lots of troubles and problems. It reached here within 2 days. Internet was very slow. Now your neighbor is also getting the same software, You get it 2 days, and now it will get in 30 minutes. Why 30? Because your neighbor is near to you. Now you are are acting as a server. First, you was a client, you got it from American server. Now your neighbor want to download same thing. So uTorrent and BitTorrent was acting your PC as a server. Now your PC is sending the data to another neighbor. Let's say if anybody is near to you, so they want to download it very near, he will get maybe in 15 minutes. So he was a server, now you was a user. Now you will be server, so this will be user. So in this, BitTorrent, uTorrent, they were working as a peer-to-peer architecture. We say a client can be server and server can be client, something like this. So they were interconnected. So we say this is approach as a C decentralized, especially we used to getting it with a larger file before P2P architecture, especially BitTorrent, uTorrent. So this is the things like, everything was centrally connected, decentralized. Yeah. This got like this is the same thing. So maybe I would say a peer-to-peer architecture provides an example. So you need to say BitTorrent, uTorrents are the example of real case studies, real application world. I hope so. This is just information. So BitTorrent tier-to-tier architecture, peer-to-peer architecture. So what does it mean? So these are the application. We are working on application layer, not again anything else. Yeah. So what are the advantages? Simple, resilient to failure. It's easy. And this is disadvantage means security is a big issue. If anything bad happened, here's all the PC, whatever, whoever use BitTorrent, so they will be affected. This is disadvantage. And this is easy, so you don't need to spend a lot of money in vendors just because they are centrally connected with each other. Yeah. Let's finish cloud computing quickly, then I will stop. Maybe there are plenty things very best, so we have covered. Cloud computing. Yes, please.
Sir, my question is that what kind of architecture is used by our internet service providers? Like we see our social media applications, there are a number of data, similar data is showing on my device and my the other ones using in similar area.
Yeah, so more like, social media, they are one of the gigantic company like, WhatsApp, the Oracle, FaceTime, whatever you are using recently, Facebook, they are one of the biggest producer of, social media. So definitely they are based on 3-tier architecture. They have lots of money. They want resiliency. Otherwise, let's say you are talking to anyone from Europe to America, it should just take less fractions of time based on fiber optics thing. Why? Because they are 3-tier architecture. Their databases are separate, their physical things or logical things are separate, their presentations are always separate, they are interconnected. This is the way only we are working here. Any bigger company, whatever you find, they work with 3-tier architecture, definitely yes. And 1-tier, 2-tier, they are just, let's say you want to create a WordPress document. So you want to save money. You don't want to buy lots of, hosting, web hosting, lots of security. So you would say, okay, I'll use free template. I'll use WordPress, very cheaper solution package. So there might be, the 2-tier and 1-tier, something like this, this is happening. Yeah. Okay, so we will discuss in later. Let's hopefully, yeah. And cloud computing. Let me finish very, very quickly. Cloud computing. Maybe some students they are wondering, like, the computing is inside the cloud. This is wrong completely, but looks like it's something similar. Cloud computing means something like, we have thousands of server. We have thousands of virtual machines. So we have thousands of platform. We have thousands of application. Who is going to do it? Let's say Cisco is not just one server. YouTube is not just one server. They have servers inside Europe. They have servers, millions servers, thousands servers globally connected. I will show you the internet map later on. So we say they are connected. Let's say YouTube, one server in America, one city, another server in the city of America, another server in the city of America, another city in like Canada, Mexico. They are just connected. We say they are cloud computing. Yeah. Why we say cloud? Because if you would like to purchase any service, let's say you want to buy any server from the Google. Let's say this is Google, this is Google, this is Google services. Or let's say this is Microsoft, and you want to buy Microsoft in London campus, UWS London campus, Paisley campus. So what will happen? So University of West of Scotland is not going to create Microsoft server physically in the United Kingdom. Never. because Microsoft servers need to be purchased, need to be maintained, need to be configured, takes lots of years to design all these things. You need to cable them under the ocean, you need to configure them with security, you need to connect them with all the continents of the world, America, Europe, Asian, African, everything. So you can't do it, UWS can't do it. So University of West of Scotland, they want to use Microsoft server. So what they are going to do, they need a Microsoft team, they need Outlook 365. So they just need to say, okay, we have 5,000 students and 5,000 staff. We need a server from your company just for 10,000 students, 10,000 staff. So what Microsoft will do, Microsoft will create a server for them. This is already created. They are not creating, but they will deploy, especially for the UWS, the domain things like uws.ac.uk, student.ac.uk, something like they will just deploy. So whenever you need it on demand, just let them pay to Microsoft. Microsoft has to do all things for you. That's why we are using Microsoft services without any problem, but just university is paying to them only. And they are connected globally. If you want to save anything, OneDrive, it's there for us. Why? Because they are doing it here. So cloud computing is something like, we have massive servers physically connected more than years before, like 20 years, 30 years, 50 years. They are already designed and deployed. Every time they are modified, but we are just paying to them. They are giving us services. If you want to get application, they will give just application on server. If you want to pay data storage like OneDrive storage, Dropbox, something like this, Ice Drive storage, you need to pay them. They will create a server for storage remotely, not into your spaces, premises. This is all about the cloud computing, meaning the on-demand availability. If you need any digital storage, let them pay. They will create for you the storage database. If you want any platform, let them pay. They will create any platform for you. Let's say, do you know anybody Corel Draw? If I'm saying AutoCAD, let's say you want to design AutoCAD, a very, very difficult code, like, the AutoCAD needs to be run on, one of the high power performance machine. You need a high power performance machine, and you need one of the heaviest graphical processing unit. If you don't have it, so you need to buy graphical processing unit. Maybe, for GPU, you need to pay £4,000, £5,000. It's very expensive. Rather than buying GPU and you are just working 1 year, 6 months project, so I would suggest just pay to the cloud computing. They will provide a remote infrastructure platform for you with the GPU performances, so you can work, and they will provide application of AutoCAD as well. So you don't need to buy a license. If you buy it, you will pay £200. Just give them £30-40 per month. They will give to you. If you don't have GPU, don't buy £2,000-4,000 NVIDIA kind of things, GPU performance things. So this will be expensive. Just pay to them. They will create an instance for you. You can use it for a few months just to save. That's why we say cloud computing means that demands availability. Whenever you need it, let them know. You just pay them monthly basis. They will give everything to you. Yeah. This is all about, all things they are going to do them. So you don't need to do, they are going to, they will just give you the login detail. That's it. So cloud computing, there are lots of software as a services, platform as a services, infrastructure as a services, whatever you want, let them know, they will do it. Yeah. You want to create workspace, you want to create any Amazon web services, let them know, they will provide it to you. You want any platform, as I said, your GPU things are AutoCAD, they will let you do. You don't need to do. If you want any infrastructure, you are starting a business and you need to install lots of rack spaces, coding, it will be wastage of time and money. So you don't need to do it. Just pay to the cloud computing, they will do everything for you, whatever you needed in your company, they will deploy with the accessibility. Like UW is doing ULA thing, Microsoft thing, they are going for all these things, services for platform. If they need an infrastructure, they are going to pay to them, they are going to rendering all these things. Yeah. This might be not correct, so please check this later on. There are some information, outsource and not outsource. Every time it's going to change it. Yeah. And how you are going to check it, so it depends, like you are a business owner in a few years. So let's say like your business maybe right now it's just 100 staff right now and 2,000 consumer or user. So you think about infrastructure is very, very limited right now, but don't underestimate it. Maybe in London, it should be increased, your staff will be 500, your staff and your customer will maybe more than 10,000 customers. So what you need to do, you need to think about your infrastructure will increase slowly. So you need to buy any infrastructure, whatever can support after 1 year. If you buy just for 100, 500, no, it should be wrong for you. Think about the future capability. It should increase. So maybe there should be an update possibility. So you have to be very careful the deployment and scalability level. Yeah. In this way, you are going to buy. So this is all the same thing we discussed client server architecture, how the web server and websites, they are working. Just sorry, I'm just talking. Sorry, I need to finish as soon as possible. And this is the same thing we have discussed, like front end and back end things. Front end you can check, and back end means so anything which is beyond. This is the same thing. Let's say you wanted to watch YouTube, so YouTube request was gone through to the web server, the application server. This is database server. And there's might that web server, what it will do, it got YouTube video for you. So maybe it's multiple page access, single page access. Then it's going to apply, this is Java services, cascading style sheet, the HTML, the button appearances, images depend. Maybe you want to watch on 7-inch screen. Maybe you want to watch on 100-inch screen. So it depends. So these guys are going to change everything for you once before it's rendering back to you. And make sure this is the something similar we discussed, but don't worry, DOM is not for you. I know this is document object model. If white way, you can work with web services, web API, so you can use this bit later on. Okay, guys, so let me finish. Front end, this is the visual parts of the website, and the back end means like, more like the complex thing which you are not able to see, but they are definitely working, Java, Python, .NET. If you are familiar with this, need to know very well what are the front end, what are the back end, and what are the single page application, multiple page application. It's just simply like, if you are clicking anything, Google, so we are not going to, can you check? This is multiple page app rendering. So when we click on one page, so it multiple pages coming. If something is coming inside the same page, we say single page access, something like this. I clicked it, so it was in the same page access. This is just a website rendering, nothing to worry about. Maybe I lost. So multiple page access is rendering multiple pages, true or false. You have to say yes, very simple. If I'm asking MPA, multiple page access, like Google is an example of multiple page access, yes or no. So you need to think about this very well. If you click any site, any button inside the Google, does it give multiple or does it give a reference single page? So you need to think about it. Then you need to select the question answer. Yeah. Okay, guys, so server-side deployment. So let me finish quickly. Monolithic, and there are some microservices architecture. Monolithic means, so as name suggests, monolithic, entire service built as a single code. We say client, server, database. They are this development inside one architecture. We say monolithic. These are the cheaper, slower, like smaller project. If it's say the microservices, micro mean again the bigger companies, we say, let's say you are buying anything from Amazon. So Amazon definitely is using microservice architecture, right? They are loosely coupled. They are first thing, second thing, third thing, payment thing, catalog things, everything is separately coupled. So they are designed with separate engineers, separate developers. So that's why it's a faster, reliable. Everything is separate. We say mono, don't worry, this is not for you, this is just information. And email is all about the same thing, like client server architecture, we say. So the text-based simple mail transfer protocol, this is all about the things. Okay, guys, so this, please read it, how email is working. We discuss same thing. I'm not wasting too much time. So this is just from the book. I took it and posted it in. This is the header and footer and body, all these things. Let's finish it. Yeah. These are the very, very simple thing we have discussed more likely before. What are the SQL shell? What are the DNS? Hopefully you are familiar right now. So please, you need to recall this again and again. Otherwise, maybe I will say DNS, HTTP, just leave them, please. Yeah. Okay, guys, so overall, so what we discussed, so we just covered all about the application layer, the one of the top level layer of OSI model, not top level, we say highest level layer, where we say the physical representation, the appearances, the interaction, the button, which are giving an abstraction of all the things. Let's say you say youtube.com. So all this will happen. We don't need to be aware about this thing because application is working with as an intermediary with all the protocols working behind the logical things. So this is all the thing. And what are the application? Google browser, all the thing, thin client, thick client, laptop, all these are known as an application. Yeah. I hope this is all done for now. I hope you listen and please make sure there will be plenty question coming very soon to your class test. Yeah, you need to be very, very careful. I'm not asking create as a microservices architecture. No, I would just ask what are the microservices architecture? What are the logical services? This is the way everything will come from here. You don't need to worry. Let me take your first attendance, then I will answer some question. Then hopefully we have to join again 11 o'clock. Definitely for lecture. Tutorial is very difficult, but I will let you know something today. Where is attendance? Let me check. Please turn off your microphone, guys. So those who are speaking a lot, this means they are not listening. Please make sure you are in recording. So be careful every time. Because somebody, I don't know who is this. Sonia. Please, if you have any question, let me know now.
Yes, sir.
Yes, sir. The audio recording, can we get it, sir? The audio recording.
Yeah, should be there. Otherwise, I will share you later on. Don't worry. Yeah, hopefully you will get it from the same team link. Otherwise, I'll share you the recorded version.
Okay.
So let me stop now. So at least you can ask any question freely. Yeah? Any question?